الله الرحمن الرحيم. We are still in this topic, which is the relative maximum and minimum of some continuous function. Last time we spoke about the first derivative test, and we said that to find the critical minimum or the relative maximum or relative minimum, we applied the first derivative test, where we need to check the sign of the first derivative of the given function. Find the critical point, then test the sign of the first derivative. For today, we are going to discuss the second derivative test. Second derivative test. Second. And the statement of the theorem says that suppose that we have that f is twice differentiable. At the point x0. Then number one, f prime at x0 equal to 0 means x sub 0 is a critical point. And if double prime, the second derivative, is greater than 0, then f has a relative minimum. Second case, number two, f prime x0 equal to 0 and f double prime of x sub 0 is less than 0. Then the function has a relative maximum. This is the second derivative test. We are checking the sign of the second derivative. Now the third case, if the first derivative x equal to 0 and if double prime at x sub 0 equal to 0 also. If both of them are equal to 0, then we can say by the second derivative test, now concluded. It means we cannot say whether it is relative maximum or relative minimum. In this case, we have to check or to use the first derivative test to check. So we need just to go back to the first derivative test to say whether it is relative maximum or relative minimum. So in the third case, if the first derivative is equal to 0, second derivative is equal to 0, then we cannot say anything. It might have relative maximum or relative minimum, or maybe it doesn't have any one of them. Now to apply this test now, let's take one example or two. Find the points of relative maximum or minimum, if any. Number one, have f of x equal to 3 x to power 3 plus 4x square minus, let me change the function. We use the same example as before, x to power 5 minus 5x to power 4 plus 5x to power 3 minus 7. And I need to find the point of relative maximum or relative minimum. I can apply the first derivative test, but for this example, I'm going to use the second derivative test. In both tests, I have to find the critical point. In both of them. Number one, find the critical point. That will be the derivative of x equal to 5x to power 4 minus 20 x to power 3 plus 15 x squared. Make it equal to 0 and solve for x. We have 5x squared as a common factor. That will be x squared minus 4x plus 3 equal to 0, or it is 5x squared x minus 1 and x minus 3 equal to 0. This means the critical points are 0 from the first one, 1 from the second one, and 3 for the third one. Now for the second derivative test, we have to find the second derivative. Differentiate for the second time. I will have 20 x to power 3 minus 60 x to power 2 plus 30x. Now I need to find the value of the second derivative at each one of the critical points. So I need to find the value of the second derivative at 0. When x equal to 0, which is the first critical point. You can see by the substitution, I will get 0. Replace x by 0, it is 0. This is the third case of the theorem. If the second derivative is equal to 0, it means there is no conclusion. It means that it might be relative minimum or relative maximum or none of them. In this case, just to be sure about it, we can go back to the first derivative test. In this case, use the first derivative. In the first derivative test, I have 0 and I have 1. I need to check around 0. So this will be 1/2 as a testing point and minus 1. This is the sign of the derivative. Replace x by minus 1 in the first derivative in this one. If you replace x by minus 1, you will have positive sign. If you replace by 1/2, it is positive sign also. So the derivative or the first derivative is not changing the sign around the 0, which means there is no relative maximum or minimum at x equal to 0. If the second derivative at the critical point is equal to 0, then check the first derivative test to see whether that we have relative maximum or relative minimum or none of them. Now for the second critical point, x equal to 1. Also, if we apply the second derivative test, replace x by 1 in the second derivative, in this one. If you replace x by 1, you will get to 20 minus 60 plus 30, which is equal to minus 10, and this is less than 0. Negative less than 0, which means relative maximum at x equal to 1. The function f has a relative maximum at x equal to 1. Third critical point, second derivative f prime at 3 is equal to 20 multiplied by 27 minus 60 multiplied by 9 plus 30 multiplied by 3. Replace x by 3 in the second derivative. And you will see 20 multiplied by 27 is 540. (540) minus 540 plus 90. That will be is 90, which is greater than 0. This is greater than 0. And if the sign of the second derivative at the critical point is greater than 0, it means relative minimum at x equal to 3. This is the second derivative test. Check the sign of the second derivative at the critical point. Take another example. Number 2. F of x equal to 1/3 x to the power 3 minus 3 over 2 x squared minus 10x plus 5. So step number 1, find the critical point. Find the derivative of the function, which is equal to x squared minus 3x minus 10. This is the first derivative. And to find the critical point, make it equal to 0 and solve for x. If you solve for x, you will have x minus 5 multiplied by x plus 2 equal to 0, which means the critical point will be 5 and 2. Sorry, minus 2. 5 and minus 2. First bracket will give me 5, the second one is minus 2. Now, for the second derivative test, we need to find the second derivative. That will be 2x minus 3. Let's differentiate this one. 2x minus 3. Find the sign or check the sign of the second derivative at the critical point. F double prime at 5 is equal to 10 minus 3. Just replace x by 5. It is 7, which is greater than 0. It means relative minimum at x equal to 5. So the function has a relative minimum at x equal to 5. At the second critical point, f of minus 2 or f double prime of minus 2, replace x by minus 2, it will be minus 4 minus 3 equal to minus 7, less than 0. So it means we have a relative maximum at x x equal to -2. This is the direct application of the second derivative test. Find the critical point first, then check the sign of the second derivative and see if it is positive, then we have a relative minimum. If it is negative, we have a relative maximum. And if it is equal to 0, there's no conclusion. We have to go back to the first derivative test to check whether that we have relative maximum or relative minimum, or maybe none of them.